The following is the video solution from JSDT Solutions. Question 9 says, the graph of h of x is equal to negative x cubed plus ax squared plus bx plus c is sketched below. And we have a and b, which is 6 and 0. Okay, so this is 6 and 0. These are turning points of h. And then they tell us that t is this point 3 and y, so it just has a y value missing, and it's a point on h. The graph of h passes through the origin. Okay, so that should tell us something. If it passes through the origin, then it means it has a common y and x-intercept here. But that still means the y-intercept is equal to 0. Okay, let's keep that in mind. And 9.1 says, show that a equals 12 and b equals negative 36. Okay, so the equation we have, you can see that we have a, b, and c. But we know that this is the origin and the graph passes the origin, meaning that c, that y-intercept, is equal to 0. That is the y-intercept over there. So we can just state that first. C is equal to 0. And so our equation is now h of x is equal to negative x cubed. And that was plus ax squared plus bx. So plus ax squared plus bx. So we have to find two missing variables given what? So the only complete point here that they have given us is this point B, 6 and 0. There's no other point that is complete. We don't have this. This is just 3 and something else. So we can only use 6 and 0. But think about what 6 and 0 is. 6 and 0 is a point, specifically an x-intercept, but it's also a turning point. So this information can be used twice. And this is how we're going to do it. So we're first going to use it as a point, using 6 and 0, and then we'll use it as a turning point. So as a turning point, remember that at that point, okay, of 6 and 0, this is where the gradient of this function is equal to 0. Okay, the gradient of the graph of h at x equals 6 is 0. So we'll use it like that, meaning we will use it as h prime of 6. Okay, so the gradient of the function at the point where x is equal to 6, that gradient is equal to 0. And these are the two ways we can use it to find a and b. So the point 6 and 0, we're just going to take this as a point and substitute it in place of x and y. So we're saying in place of y, 0 equals negative and x is 6 all cubed plus a times 6 all squared plus b times 6. Okay, so 0 is equal to 6 cubed is 216. So this is negative 216. And then this is positive 36a and plus 6b. Okay, so we can just make 6b the subject since they are all divisible by 6. So we'll transpose these two. And so we have 216 minus 36a is equal to 6b. And they're all divisible by 6. So if we divide both hand sides of this equation by 6, b is equal to this divided by 6. Okay, if you say 6 cubed divided by 6, that's 6 squared, which is 36. And 36 is 6 squared. So 6 squared divided by 6 is 6. So we have minus 6a. Okay, and this is what we have. And that's our first equation. We'll see if this one can also be written in terms of b. Okay, now we're using 6 and 0, okay, that point, as a turning point. So specifically at the point where x is equal to 6, the gradient of this function is 0. So how do we find the gradient of this function? We find that by deriving it. So we're going to derive h of x. So now we get h prime of x is equal to, and its coefficient times exponent. So that is negative 3x squared, then plus 2ax, okay, and then exponent minus 1, and then plus b, and the x will fall away because exponent minus 1 is 0, anything to the power of 0 is 1. Okay, so this is what we have, and we're specifically finding the gradient of this function at the point where x equals 6. So negative 3 times 6 all squared plus 2a times 6 plus b. And we're substituting in place of this. We're saying the gradient at the point where x is equal to 6 of this function is 0 because we have a turning point there, is equal to, And then this gives us 36. 36 times 3 is negative 108. And then that's positive 12a plus b. And you see how b can also be made the subject here. So let's leave it on the right-hand side. And we have positive 108 minus 12a. Okay, great. So we've got b is equal to b, okay? So we can just equate them. B equals b. And we say this is, let me just put it on this side. So b is equal to b. And we're saying 36 minus 6a equals 108 minus 12a. If we transpose the 12, it becomes positive. So it's 12a minus 6a, which is 6a. And then 108 minus 36. And so we have 6a is equal to, that will be 72. And then if you divide both hand sides by 6, a is therefore equal to 12. Okay, so there we go. We've got a. And now b, we can just use the easier equation to solve for b. So we'll say b equals, we have 36 minus 6 times 12. And b is equal to 36 minus, that gives us 72. And then it is going to be, this is double of 36. So this is negative 36. And that is our answer. So a is indeed equal to 12. And b is equal to negative 36. Moving on to the next question. The next question says calculate the coordinates of a. So the coordinates of a. What was a? A is the other turning point. So just find the other turning point. Now that we have a and b, we can complete our equation. So our equation is now h of x is equal to negative x cubed. And then in place of a is 12, so there's positive 12x squared, and b is negative 36, so that's minus 36x. And now we can find the stationary points because a is one of the stationary points. So to find the stationary points, again, we're using the idea that we know that at the stationary points, the gradient of the function is equal to 0. So we're going to find the gradient by deriving this. Is equal to, and coefficient times exponent is negative 3x squared. Then we have plus 24x and minus 36. And now we're saying the gradient of the function at the turning point is equal to 0. Okay, so then we rewrite this. And then you see that they're all divisible by negative 3. So we can divide both hand sides of this equation by negative 3. They have a common factor. So therefore, now we have x squared and then minus 8x, and that will give us positive 12 is equal to 0. Okay, factorize, open up two brackets, set it equal to 0. X multiplied by x gives us x squared. And now we need factors of 12 that can give us 8, negative 8 specifically. So because only the middle is negative, it means these two must be negative. So we could use like negative 2 and negative 6 because negative 2 times negative 6 is positive 12. But negative 2 minus 6 is negative 8. Okay, so that is minus 2 minus 6. And so therefore, x is equal to 2 or x is equal to 6. Great. We know the one that x is equal to 6. We know where x is equal to 6. It's at b. We are specifically going to focus on a. So this has an x value of 2. And to find its y value, that corresponding y value, just substitute this x value of 2 into the original equation of h, because this will give you y values specifically for whichever x value you substitute. So in place of x, we'll substitute 2. So like this. And so h of 2 is simply equal to, and we'll just put that on the calculator, and h of 2 is equal to negative 32. So that would be the coordinates of a. We can finally say the x value is 2 and the y value is negative 32. And that is our answer. Moving on to the next question. Question 9.3 says, calculate the value of y. So what is y? And looking at our graph, you see that y is over here. Okay, this is where the x value on this graph is 3. So just substitute that x value to get its corresponding y value. Okay, so we'll need the equation of h again. And we're going to substitute the x value of 3. Okay, so we'll say y is equal to, and let's substitute. So y is finally equal to, and this is negative 27. And that's all they asked for, the value of y. Moving on to the next question. The next question, 9.4, says, is the graph of h concave up or down at the point t? Okay, show all calculations. So the point t is that point where x is equal to 3. To find out where it is concave up or down, we can actually see how it's curved. So here we can see that it's concave up, and here we can see that it's concave down. But we can't just say, oh, it's on this side, so it's concave down. We have to actually find out. So how we can find this is by finding the points where the concavity changes. And this is at the point of inflection. Okay, so if we find out what exactly that x value is, we will know based on where 3 is, okay, and based on whatever that number is, we will know whether it is in the region that is concave up or concave down. Okay, so with this, we're going to need the shape of that graph. And we have to find that x value of the point of inflection. So you can actually find this because you have the full equation of h. You can find this by finding the second derivative and then setting it equal to 0. But another easy way to actually just do this is just say, find the second derivative and find out where it's concave up. This is where the second derivative is greater than 0. And I can also just see another way to do this just because they gave us these turning points. So you see the turning points, they're very useful. If you find the midpoint of your turning points, those x values specifically, you will find the point of inflection. So the middle of 2 and 6, okay, if you find that, that will be the point of inflection. And the reason why is because this is a cubic function. If you derive it, you get a parabola. So notice that this cubic function had the coefficient of x cubed be negative, meaning when you derive it, it will form a concave down parabola. Now, the thing about this parabola is that at its x-intercepts, it's going to have the same x value as the turning point on the cubic function. Okay, so those would be the exact same x values. And so when we have that, if you took the x values of the stationary points, right, those x-intercepts of your parabola, and you found the midpoint of them, do you see that that will be the turning point of this parabola? So that turning point, that x value, it's going to be the exact same x value as the x value of your point of inflection. So that's the relationship there. So you could either find that x value of the point of inflection by deriving this graph, okay, twice, or you could find it like this. So I could say 2 plus 6 divided by 2. That middle will give us that point of inflection's x value. Okay, so I'm just going to find that by saying this is where x is equal to 2 plus 6 divided by 2. That's 8 divided by 2, which is 4. So x is equal to 4. Great. So now we know that the point of inflection occurs at x equals 4. Remember that your function h looked like this, right? And of course, it passed the origin. So because it looks like this, now we know that this is where the point of inflection is at x is equal to 4. Do you see now that all through here, this is where it's concave up. So for values where x is less than 4, that's where it's concave up. And we can actually put that down. We can tell them, we can see that it is concave up. Now I'm just going to actually write the actual words. I don't need to write this. All I would have to say to show them that it's concave up is tell them that the second derivative of this is greater than 0. Okay, this is where it is concave up. It's concave up where we can see that x is less than 4, all through there. And then it's concave down, it's curved down like that, okay, a sad face, where the x values are greater than 4. Okay, if you line these down to the x-axis, these are values that are greater than 4. Okay, concave down where x is greater than 4. So with this, to find out the concavity at point T, remember where T is. T is the point with an x value of 3. So where will it lie here? Is it going to lie before the 4 or after the 4? 3 is before 4, so it's here. So that means that this graph is concave up at T. So T could be like there. Okay, so it is concave up at T. And you can tell them, you just finally conclude the graph is concave up at point T because we can see where that is. And just tell them because we know that 3 is less than 4. So it falls into this category. Okay, so there we go. And I will just leave that along with this graph, just showing where that is. And that is enough of an explanation. Okay, alternatively, you could also just find the second derivatives equation, and then you could take that x value of 3, right? Because we're trying to find out the concavity at that point. And you could just substitute it. You'll see that it will give you a value that is greater than 0. Okay, so that's another way. And that is it for this question. Moving on to the next question. The last question for question 9.5 says, determine the coordinates of the point of inflection. Okay, we already have the x value of the point of inflection. So, and we have the full equation of h. Just substitute that x value of 4 into the equation of h so that you can find its corresponding y value. Okay, so we know that we just have to find h of 4, and let's substitute. Okay, and h of 4 is equal to negative 16. So our point of inflection, we can just conclude, is 4 and negative 16. And that is our answer. And that is it for question 9.